Hello everyone. We are still in the introductory topics for the Calculus 1 course. This section will start examining basic functions, and in particular, this video will pertain to lines. Linear functions, or if you prefer lines in R2, traditionally the relationship y equals ax plus b is used to represent a line in R2. We call it the canonical form. Any point P of the line must have coordinates that satisfy the relationship. What this means is that if xp, yp is actually on the line, then those coordinates must make the equation yp equals a times xp plus b true. The line's equation shows two different parameters, a and b, that characterize the line and distinguish it from any other. A is the slope of the line and represents the rate at which the y component changes for every unit increase in x. More specifically, if point P1 and P2 are points of the line, then the line slope is obtained from the ratio y2 minus y1 over x2 minus x1. Frequently, you'll read delta y over delta x in some math books when generating the definition of the slope. B is the line's y-intercept, that is, the y-coordinate of the point where the line crosses the y-axis. In other words, the line that has B as its y-intercept will cross point 0b. Line 1, depicted in blue, crosses the y-axis at coordinate point 0, minus 4. Thus, b equals minus 4 will be its y-intercept. The slope can be evaluated by observing that point 2, 0 also lies on the line, and therefore the slope will be 4 over 2 when we compute the change in y over the change in x. This means that for every 1 unit displacement in the positive x direction, the line's y value will increase by 2 units. With an a of 2 and a b of minus 4, the line's equation is 2x plus minus 4, or simply y equals 2x minus 4. Line 2, depicted in red, crosses the y-axis at coordinate point 0, 6. This means the parameter b is equal to 6. Its slope can be evaluated by observing that point 2, 0 also lies on the line. The slope is then calculated by evaluating the change in y over the change in x using the 2 points 0, 6 and 2, 0, and the ratio comes out to minus 3. This means that every 1 unit displacement in the positive x direction will result in a 3 unit decrease of the y value. With an a of minus 3 and a b of 6, the line's equation is y equals minus 3x plus 6. Finally, line 3, depicted in green, crosses the y-axis at coordinate point 0, 4, meaning b is 4. In addition, you'll notice that the slope is 0 as there is no change in y. Therefore, all points on line 3 must obey the rule y equals 0x plus 4, which we would simply write y equals 4. A vertical line is somewhat an exception to the rule when it comes to formulating its equation. It cannot be represented using the form y equals ax plus b, simply because the slope, which is obtained from a change in y over a change in x, would create or would generate a division by 0. 2 points being one above the other would have no change in the x direction. So for vertical lines, we'll simply write the equation in the form x equals c. In this example, the red vertical line is located at x equals minus 1/2, and that would be its equation. The green line is vertical and all of its points have an x-coordinate equal to 1/2. X equals 2 would be the equation for the vertical line represented in black. Now we'll examine an alternative way of writing the equation of the line. This is called the point-slope form. So y minus y1 equals a times x minus x1 is also a way of representing a line's equation. This form can be used if the slope of the line is a and the line crosses a known coordinate point x1, y1. The equation itself is obtained from the definition of the slope. If you recall, a is obtained by finding the ratio of y2 minus y1 over x2 minus x1, and by recognizing the fact that the value of a should not depend on which pair of points are selected from the line. The line's inclination through x1, y1, x2, y2 should be the same as the inclination through x1, y1, and any other arbitrary point, xy. Therefore, the slope can be found either from the ratio y2 minus y1 over x2 minus x1, or from the ratio y minus y1 over x minus x1. We can cross-multiply the x minus x1 term, which actually reveals the point-slope form we were discussing earlier. Here's an example where we'll find the equation of the line that contains point A, 1, 5, and B, 3, 2. First, we'll use an approach leading to the canonical form, y equals ax plus b. The slope of the line is obtained by finding the ratio of the change in y over the change in x. As we go from point A to point B, we'll notice that there has been a 3-unit change. Actually, there has been a decrease in 3 units in the y component, and there has been a 2-unit increase in the x. Delta y is minus 3, delta x is 2, and therefore the slope is minus 3/2. So we have a partial equation so far for the line's equation. Y equals minus 3/2 is the A, x plus b. The y-intercept is not known, is not given, but either point A or B can be used to find the adequate value of b. For instance, given that 1, 5 must satisfy the line's equation because it is a point of the line, then we can replace y by 5 and x by 1 and eventually find the value of b that fits, which would be 13/2 in this case. The equation of the line is therefore minus 3/2 x plus 13/2. This time, we're going to try to find the equation of the same line, but using the point-slope form. The slope of the line is still obtained from the change in y over the change in x, and will still be minus 3/2. Therefore, the line's equation, when written in point-slope form, is y minus y1 equals the slope minus 3/2 times x minus x1. This time, we need not dig very deep in order to find a point that lies on the line. We could use 1, 5, just as we could use point B as well. Assuming we do take point A, then the y1 component would be 5, and the x1 component of the equation would be 1, which leads to y minus 5 equals minus 3/2 times x minus 1. We can certainly verify that the two approaches lead to the same line. Notice how, if we start from the equation of the point-slope in point-slope form, moving or distributing the minus 3/2 to both the x and the minus 1, and moving the 5 across will eventually lead us to what we found to be the canonical form. Here are some additional remarks about lines. Lines are parallel if they have equal slopes. In other words, y equals ax plus b1, and y equals ax plus b2 are parallel lines. For example, find the equation of the line that contains point Q, 4, 2, and is parallel to y equals 3x minus 1. The line we're looking for must have a slope of 3 as well in order to be parallel to y equals 3x minus 1. We can then use the point-slope form with the point Q as the known point to find the equation of the line. Y minus 2, where we're using 2 as the y1 element, has to equal 3, being the slope, times x minus 4, 4 being the x1 component. If the constants are distributed and the line is rewritten in canonical form, we will find that y is 3x minus 10. Lines are perpendicular or orthogonal if the slope of one line is the negative reciprocal of the other. In other words, y equals a1x plus b1 and y equals a2x plus b2 are perpendicular if a2 is equal to minus 1 over a1. 1 is the negative reciprocal of the other. Find the equation of the line that contains point R, 1, 6, that is perpendicular to y equal 5x plus 3. Again, the line we are looking to find must have a slope of minus 1 over 5 in order to be perpendicular to y equals 5x plus 3. Minus 1 over 5 is the slope that would be the negative reciprocal of 5, the slope of the line we're given. In addition, we have point R, whose coordinates are 1, 6 to work with, and therefore the point-slope form would allow us to assume that the line we're looking for has an equation y minus 6, 6 being the y1, equals minus 1/5 times x minus 1, 1 being the x1 term. Again, we can distribute the constants around and rewrite the equation in its canonical form. The x-intercept is the x-coordinate of the point where the line crosses the x-axis. It's obtained by setting y equal to 0 and by solving for x. For example, find the interval where line y equals 1/3 x minus 1 is above the x-axis. The line will cross the x-axis when y is 0, that is, at its x-intercept. So if y is equal to 0, then the corresponding x value is obtained through a bit of algebra and would have to be 3. 3 is therefore the x-intercept of this line. The line slope is 1 over 3, which is positive, so we know that the line must be increasing. Therefore, the line will be above the x-axis for all x beyond 3. Here is a depiction of this